All right, so just following that process from yesterday, and we do need the function and the derivative. So as I mentioned, it is a very good idea for you not to be slack and get into the habit of writing, well, the function inside the bracket is x squared plus 1. The derivative of that is 2x. And so, in order for us to anti-differentiate this, if we put in the derivative of 2, so now we've got the number 2, we've now got the exact derivative 2x, but that changes the question, so we divide it out. Then we can anti-differentiate using the rules that we've been given. So add 1 to that power, divide by the new power, and you've still got that 1/2. So that leaves you with that function divide 6 plus c. So it's all about making sure you've got the derivative. That's the key first. If you don't have the derivative, sorry, this is that last bit. Okay, so that should be the divide 6 here plus c. I'm not sure what happened there. Okay, so you must have that derivative. Look at the next one. Instead of having 2x, you've got 6x. So for me, like I said, we know the function is x squared plus 1. We know the derivative that we need is 2x. We've got a 6 in the way. Let's just bring the 6 out the front and put the 2 in. And then divide it out. So it doesn't change the question, but it just makes it a bit easier because then we know that that's what's left. So that 6 divided 2 is 3. And then we've got your x squared plus 1, add 1 to the power, divide by the new power, plus c. So if you follow that method, it will work every time. And you don't have to think too much. Take out the constant, put the one you want. That's all you've got to remember. But don't forget to divide it out. So I guess there's 3 steps. Take out what you don't want, put in what you do, but then divide it out. And then if you do that and follow that process, you're always going to end up with whatever the function is, 1 more in the power, divide by the new power. And then that final step is just to multiply that constant through. So in this particular instance, that constant does simplify quite nicely. All right, in 17, so you can see it's the same function in the bracket each time, but just slightly different constants. So we're working our way through to show you what to do with all the different types. Again, the same function, I won't redo that derivative, but that half is in the way, we don't want it. What we do want is a 2, not a half. So let's put in the 2, but then we have to divide it out. So essentially you've got a half times a half out the front. And then we can anti-differentiate like before. Add 1 to the power, divide by the new power, you've still got that quarter, which then becomes a 12th. What's different about 18? Annabelle mentioned it yesterday, but some of you may not have been up to it. What's different about it? Yeah, we don't have the x. We don't have the derivative or a play on the derivative that's in the bracket. And so because we don't have that, we can't anti-differentiate this one in the same way as all the others. So you are forced to expand this one. So that becomes x to the 4 plus 2x squared plus 1. And then we would anti-differentiate that as per normal. So that becomes actually pretty straightforward. I guess with all of these, the reminder is don't forget to add c. So when you're expanding, don't forget that middle term, because that comes from, you should know this off the top of your head by now, that comes from one bracket times the other, so you've got that x squared term in the middle. That's a common error students make by missing that. All right, and then the last ones are just a little bit more challenging. I guess these were the ones I asked you to complete. A little bit more challenging only because of the square root or cube root functions. But really, there's nothing different here. The first step you should do is just write that as whatever power it should be. So in this case, it's -1/2. And then you've got your function, which is 3x to the 4, that's in the bracket, and your derivative, which is 12x cubed. So here we've got an x cubed. We're missing the 12, so we put it in but divide it out. As I said before, if we don't divide it out, we are changing the question. But then what that allows us to do, that's going to be a 12. We've got to add 1 to the power and divide by that new power. And then finishing off ends up being divide 6. So the other two are very similar. I'll put those answers up at some point because I know some of you have already done this. Or do you want me to keep going? No? Okay. What about 22? That's a bit different. What's different about 22? How can you do it? Actually, it can't be done using our methods, right? This is one you can do on the calculator, but using our methods, we can't do it. Yeah. Okay. Okay, so it's having problems with it at the indefinite integral. It'll be able to be done between bounds depending on what the bounds might be, but at the moment, no. So we'll leave it at that. Okay, so then I've said to stop there. How are people going with these others? There's a few more. These ones are all mixed, so it's just a matter of you having a go. I'll give you some time to do that. If you've done those, then you can move on to this exercise. There is some textbook questions, but these ones are probably better if you're time poor. And your investigation, I know a few people have got some